Thank you for having me here today. I think you can hear me either way. Uh, yeah, so had, after 32 years in the chemicals industry, I had started my second career helping manufacturers adopt Industry 4.0 technology and making sure that they had not only the technology but the workforce available to be able to continue their operations. Smart Factory Institute is an organization that helps manufacturers evaluate what technologies are beneficial to them and then also make sure that they have the skilled workforce to be able to continue their operations and be productive. It's a public-private partnership operated by Peak Performance Incorporated. And again, we facilitate this intensive networking between academia, between manufacturers, between different professional organizations to really support manufacturing. Yeah, so the Smart Factory Institute is part of a global network of Deutsche Messe technology academies, and we are the only one located in the United States. These academies, again, create a unique ecosystem connecting technology providers, academia, and manufacturers. The Smart Factory Institute, Tennessee, is located at the PI Center, Partners in Industry and Education in Cleveland, Tennessee, and it's an ideal location for having the students as well as the manufacturers come and learn more about technologies. So every year, the site selection group evaluates states for the conditions that would really help attract manufacturers to the regions. And it's very clear to see that the Southeast region is the best environment for manufacturing in the United States. And that's one of the reasons why the Smart Factory Institute is located in Tennessee. We're centrally located to be able to reach a lot of these manufacturers and these manufacturers that are investing in our region. Manufacturing is a huge part of the U.S. economy. We have over 13 million workers in manufacturing. For every dollar that is spent in manufacturing, there is another $3 in the local economy that's generated. So it has a huge economic impact. But one thing to note is that despite having such a large employment, currently, this is based on August of 2024, we have over 500,000 open manufacturing positions. You can see over time, manufacturing is typically a little bit more stable than other industries with respect to turnover, but whether you're examining current trends or historical data, there is still a big concern about the manufacturing turnover because it's not so easy to replace a worker that has already been trained and is operating in a manufacturing environment. The lead time to bring that worker up to speed is a lot longer than, say, a worker in the service industry. So, manufacturers, over 70% of manufacturers surveyed say that having a qualified, skilled workforce is their top issue. And over the next decade, it's estimated that there is going to be a need of 4 million workers going into the manufacturing workforce. But unless something is done, we will have half of those jobs being unfilled. So we'll have 2 million jobs, a gap where manufacturers do not have the workforce that is needed. And we just heard a lot about the concerns about the gaps in the workforce. we need a pipeline of skilled workers as well as Industry 4.0 technology advancements, which will improve improve productivity to be able to close that gap. Instead of having individual disconnected efforts, we really need to have the companies, we need to have the different academic institutions, and we need to have the professional organizations, suppliers, everyone coming together to solve this problem. We have a lot of disconnected efforts currently, but to really get to the heart of it, we'll have to solve it together. So when we talk about Industry 4.0, it's really the fourth iteration of industrial revolutions. The difference is industrial revolutions in the past have focused primarily on the technology advancements. Industry 4.0 kind of blurs the lines between technology and the workforce. And it's really creating what we call the smart factory in manufacturing. And it changes the way that work happens, not just how work is done, but how the worker interacts with the operations. Okay, so when we're talking about the specific smart factory technologies, we're talking about advanced connectivity, data-driven intelligence, human-machine integration, and advanced production processes. And so we've already been having to interact with these technologies in our personal lives. I'll give you an example. I think probably most people drove here today. So when you got into your car and you have your smartphone and it automatically connects to your car and it's connected to the internet, that's an example of advanced connectivity. If you used a Maps app to help you get here and make sure that you're avoiding traffic delays, that data that the app is evaluating to see where the best route is, that's an example of data-driven intelligence. If you happen to call somebody as you're driving and make a phone call through your asking Siri or through your phone, that's an example of human-machine integration. And then, most likely 3D printed components for your phone or for your car helped those devices be more affordable for us. So those are some examples in our daily life. Those same types of advances are happening in manufacturing. There's a lot of focus on the technology itself, but there hasn't been a whole lot of focus on how the individual worker interacts with this technology and how that changes their jobs. It includes impacts on the design of manufacturing work, their critical knowledge and skills that they need, and also other talent management considerations. I want to talk briefly about AI because we hear so much about AI. It's not the only advanced technology, but it is a big part of the technological advancements that we see. Machine learning and deep learning are subsets of artificial intelligence. And they're similar, but they're a little bit different. Machine learning is a broad field that involves algorithms and computers to learn and make predictions based on data. Some examples include recommendation systems like what you see when you order something from Amazon and then it recommends some additional products, or fraud detection, or customer segmentation. Deep learning is more advanced. It takes, it's a specialized subset of machine learning that takes neural networks with different data, different systems, and it puts it all together. It's really that next level of predictions. It exceeds processing, and it includes large amount of data that is somewhat disconnected. Data that is actual numerical data, images, text, audio. It's taking all this information and then combining it to create a prediction or a recommendation. Examples are, a great example are self-driving cars. Self-driving cars have to take a lot of various data. It's taking data from people moving, other cars moving, sensors, information from the road, and putting it together to be able to make decisions that typically humans would make. In manufacturing, artificial intelligence can be in quality control, where before products are made, sensors or cameras or information will detect abnormalities, and adjustments can be made before the resources are spent in completing the production process. It can include predictive maintenance, again, where AI evaluates sensors that are on equipment and predict failures rather than waiting for an equipment to break down. Supply chain optimization. AI can take information to help optimize inventory levels, predict demands, help with logistics. We have process optimization, which is pretty clear-cut. It's taking information from the process and evaluating ways to improve the processes to be more productive. Energy management, again, trying to take information to see where we can conserve energy and reduce energy consumption. And then product design and development. This is where AI can help evaluate customer feedback and trends to predict what new products need to be produced in the marketplace. So when manufacturers are surveyed about the technology implementation, 92% say that they are planning in the next 12 months to implement some technology advancements. The main driver is to improve their operations. So one of the things, though, that this brings is a lot of anxiety in the workforce about how this is going to impact their jobs. So is there going to be a great robot takeover? Will automation eliminate jobs? It's really easy to see how labor could eliminate some jobs, but it's harder to visualize how improvements in productivity actually will have an overall increase in the manufacturing employment. So it's not a loss of jobs per se, it's a shift in the work that is required. Automation will reduce the need for unskilled labor, for tasks that are routine, that are physical, that are maybe a little bit more mundane. It shifts that work to higher skill, complex problem solving, and really requires a more diversified workforce. An example of how this happened in the past is when the advent of computers occurred in the 70s in the workplace. Routine jobs were replaced, but the overall impact was you had 3.5 million jobs directly lost with the advent of computers, but overall there were over 19 million jobs added to the economy. So the net effect was a job increase. It was just that instead of having people that were typing on computers and having specific individuals that were secretaries taking handwritten memos and typing them up. You had individuals that could be more productive themselves and create those memos themselves or do higher end calculations or work with the computers. So again, technology changes the nature of the work. New, efficient, connected, data-driven ways of working will become the norm. And consideration has to be made to the workforce that will be driving those changes. Work becomes more complex. It's more complex process demands and changes the role of the worker. The overall work shifts from the low-skilled, task-oriented physical work to the strategic work and requires the individual worker to evaluate a lot of information and make decisions. This changes the types of jobs and the positions that are needed in manufacturing. So as we have discussed this with manufacturers in the region, they have asked for help in preparing their workforce and preparing for these changes. The Smart Factory Institute partnered with the University of Tennessee's Industrial Organizational Psychology Department to evaluate the impact of the technology changes and the effect on the worker and the future roles that workers will have. One of the things that we have discovered is that the old way of training will not be sufficient to meet the needs of the new workers and the new workforce that we will have. So part of this evaluation included a detailed occupational profile evaluation looking at reports from Department of Labor's Occupational Information Network. These reports were carefully reviewed and analyzed to determine the impact of technology on the manufacturing positions. And these 9 common manufacturing positions are likely to be essential for the successful adoption of Industry 4.0. These positions currently vary considerably from each other in terms of the core worker requirements and responsibilities, but as Industry 4.0 becomes more fully adopted, it's anticipated that a lot of this differentiation will be reduced by the technology and the blending of the roles and responsibilities the workforce will have. And that will be good news, actually, for manufacturing companies, because that means that we can have some cross-training and we can better fill the needs at any particular time with the workforce at hand. One of the easiest ways to determine how technology can improve an operation is implement what we call the 4D model. Look at the jobs that are dirty, dangerous, difficult, or dull. Those are jobs that most easily can be changed and automated with new Industry 4.0 technology. And this will have the most significant impact to manufacturing operations and productivity. So again, not only was the ONET data evaluated to see what jobs will be most likely needed in the future, there was also an evaluation of what jobs are most likely to be at risk of being eliminated in the future. And these are some jobs that fit into those categories of being the 4 Ds. These workers we don't want to lose these workers because we need them badly, but these are the workers that will need to be retrained and upskilled to be able to perform the new jobs and the new tasks that manufacturers will have. So it's very obvious that as technology evolves and as there is a higher level of technology in manufacturing, there is going to be a need for STEM jobs in manufacturing. These positions will be essential to increase productivity and also the integration of technology into the manufacturing workplace. Some of these jobs are existing already, but some of these jobs are emerging with industry as needs change. So as we evaluate future training needs, we have to understand that the workforce is not a one-size-fits-all. We were just hearing about needing to get women and other demographics into the workforce. We really have three sets of workers. We have the emergent workers. Those are the students that are entering the workforce. These are people that are coming out of either secondary education or post-secondary education. And what they really need, they don't have experience. They have a lot of knowledge and training, but don't have experience. So earn and learn programs are very important here, where the students can have some on-the-job experience and pay for their training and their education. Then you have the incumbent worker. This is the 13 million workers that we have in manufacturing today. These workers are working full-time. They're working 40, 50, 60 hours a week. They don't have time in their schedules to go to a standard course at a community college or at a university. So these workers need to have some targeted skills training, micro-credentialing or other training so that they can have the skills that they need to continue to evolve as the workplace evolves. Then you have the transitional worker. These are the women, former military, maybe they're formerly incarcerated individuals, immigrants. These are where we're really going to need to focus on bringing more of these individuals into manufacturing. These are not the workers that have traditionally been in the manufacturing workspace. And they bring with them another set of needs and challenges and requirements. They're the ones that might need transportation. They may need child care, or as we heard earlier, elder care, or they may need some help with English as a second language. These individuals will be critical, though, to be able to fill the gaps that we will have in manufacturing. So when we talk about training with Industry 4.0, we're focused on knowledge, skills, abilities, and other characteristics that are needed to effectively respond to the changing needs. It's going to be critical to consider not just knowledge or skills, but abilities and other characteristics. You can't look at just the how to do it. To ensure the right workforce is available, to ensure that it's available to get the full gains of Industry 4.0, there was a deep evaluation that was performed by the IO Psychology Department at UTC, and they developed this 5-prong profile. Is a 5 competency framework to evaluate worker abilities and worker requirements. These requirements were identified through a data-driven future work analysis process that took data from ONET as well as inputs from a panel of subject matter experts with Industry 4.0 manufacturing experience. So when we talk about physical, that's pretty clear. That's the more traditional type of ability that manufacturing workers needed to have. Physical skills tend to be associated with the traditional manufacturing work, but they'll still be necessary. Maybe it's a different type of physical skill. Technical, again, is pretty obvious. Having technical knowledge and training to be able to interface with the new technology will be critical to make sure that the workers and manufacturers are successful. The methodological is something new. This is where you need to have workers that have the ability to see how all of the pieces of the process fit together and take information from different pieces of the process and evaluate and then make decisions and solve problems. It's really looking at being able to see the overall production process and how the system fits together and how to make adjustments so that problems are solved. This is something that in the past hasn't been a traditional entry-level type of skill that manufacturer workers have. Then again, social is also important. A lot of the tasks in the past have been individual worker tasks in manufacturing. Now people are working in teams. Also related to this need, because of the increased globalization, it has to include being able to relate to other cultures or maybe even speak other languages and be able to interact with a more diverse workforce. Intrapersonal is looking within. And again, this will be very critical because one of the key components of intrapersonal skills is flexibility and adaptability. Workers are going to have to be more flexible and adaptable because things will be changing quickly. And they have been changing quickly. We've seen this in our personal lives. People will have to be able to adapt to these changes in the workforce. So, the implications and next steps really for manufacturers, the first step is to perform an assessment to develop an Industry 4.0 roadmap and see where the biggest priorities and the biggest gains can be made in the workplace. Then develop a change management strategy that involves not only the equipment changes, but how to prepare your workforce for the changes. And then part of that is considering those future work requirements and making sure that you are preparing the workforce for those changes before they happen so that they can move into that new technology seamlessly. And an active talent management program to manage performance of employees. There are two large reports that this information came from the IO Psychology Department. You can download the reports if you want to scan those QR codes, or you can go to the website at www.smartfactoryinstitute.com. You can also get the reports. But the first one is really focused on how technology is going to be changing in the transformation of manufacturing. And then the second report focuses more on what is that impact to the worker and the workforce, and how can manufacturers make the changes now to adapt. So, again, we surveyed manufacturers in Tennessee through the Tennessee Manufacturers Association asking manufacturers what items, what would be most beneficial in implementing the Industry 4.0 roadmap. And you can see that overwhelmingly, manufacturers need help in developing their roadmaps, understanding what changes they need to make. They'd like to learn from others what are the best practices. When you think about it, we hear about the large manufacturers like the Blue Ovals, but 90% of manufacturers have less than 250 employees. And these smaller manufacturers don't have the IT department or the maybe even the HR departments, the resources to be able to do this work themselves. So they're really looking for support, and that's one of the things that evolved into the development of the Smart Factory Institute. We started operations in 2001, kind of still in the middle of the pandemic, and have been operating in the Cleveland, Chattanooga area since. But again, the focus of the Smart Factory Institute is to bring these different manufacturers, technology providers, academia, it also the professional organizations together and be able to overall help manufacturers improve their operations, which has a huge impact on our economy.